questions 11 through 20 on the 2009 Grade 7 Gauss Math Contest. Scott challenges Chris to a 100-meter race. Scott runs 4 meters for every 5 meters that Chris runs. How far will Scott have run when Chris crosses the finish line? So our ratio of Scott to Chris is 4/5. So Scott over 100 meters, which is what Chris will have run when he crosses the finish line in a 100-meter race, is equivalent to 4/5. So cross multiplying, you get 400 is equal to 5s, and therefore s is equal to 400 divided by 5, which is 80. So number 11, the answer is E. PQR has an area of 27 centimeters squared, and the base is 6. What is the height of PQR? The area is 1/2 base times height. The base is 6, and the height they have represented as h. They tell you the area is 27, so this becomes 27 is equal to 3h, and therefore h is 27/3, and that means h is equal to 9. So number 12, the answer is A. The product 60 times 60 times 24 times 7 equals. So they've got 60 times 60 times 24 times 7. Well, the 7 represents the number of days in a week. 24 represents the number of hours in a day. 60 represents the number of minutes in an hour. And 60 represents the number of seconds in a minute. So this all is the number of seconds in 7 days, which is a week. So the number of seconds in a week, so 13, the answer is D. Which of the points positioned on the number line best represents the value s divided by t? So here are s and t. They don't give us actual numerical values, but we can approximate. We can say that s is approximately 1.5, t is approximately 1.6, let's say. So s divided by t would be 1.5 divided by 1.6. And that is just a little less than 1, so say 0.9 something. Approximately 0.93. Well, which of those letters represents a value just less than 1? Well, it's this one right here, R. So number 14, the answer is C. The product of 3 different positive integers is 144. What is the maximum possible sum of these 3 integers? So A times B times C is equal to 144. And we want the maximum possible value of A plus B plus C. So if you fiddle around with this, you can say 1 times 2 times 72. If that is our A, B, and C, that would mean A plus B plus C would be 1 plus 2 plus 72, and that is 75. And that is the maximum that you can possibly make those 3 different integers. So number 15, the answer is B. A square has an area of 25. A rectangle has the same width as a square. The length of the rectangle is double its width. What is the area of the rectangle? So here's a square, and then we want a rectangle that has the same width but double the length. So they tell us the area is 25, so that means the side must be 5 and 5. This rectangle has the same width, but its length is double the width, so the length is 10. So therefore the area of the rectangle is length times width, which in this case is 5 times 10, which is 50. So number 16, the answer is D. Vanessa set a school record for the most points in a single basketball game when her team scored 48 points. The 6 other players on her team averaged 3.5 points each. How many points did Vanessa score to set her school record? So 48 points minus the other 6 players, which is 6 times 3.5, and that would equal Vanessa's point total. So this is 48 minus 3 times 7, which is 21. And therefore Vanessa scored 27 points. So 17, the answer is E. X, y, and z are positive integers with xy equals 18, xz equals 3, and yz equals 6. What is the value of x plus y plus z? xy is equal to 18, xz is equal to 3, and yz is equal to 6. So if you were to isolate for y, you get 18 over x. Isolate for z, you get 3 over x. And then now we can substitute these two into here. So yz would be 18 over x times 3 over x, like that, and that is equal to 6. So cross multiply, and you get 18 times 3 is equal to 6x squared, and then x squared would therefore be 18 times 3 divided by 6, and x squared is therefore 18 divided by 6 is 3, so 3 times 3, and that means x is 3. If x is 3, then y would be 18 over 3, which is 6, and z would be 3 over 3, which is 1. So x plus y plus z is 3 plus 6 plus 1, and that is equal to 10. So number 18, the answer is B. A jar contains quarters worth 25 cents each, nickels worth 5 cents each, pennies worth 1 cent each. The value of the quarters is $10. The value of the nickels is $10. The values of the pennies is $10. If Judith randomly chooses one coin from the jar, what is the probability that it is a quarter? Our quarters, nickels, and pennies are each valued at $10, but I'm going to convert them to cents since I have to work with cents. If I divide by 25 cents, it will give me the number of quarters, which is 40. If I divide by 5 cents, it will give me the number of nickels, which is 200. And if I divide by 1 cent, I get the number of pennies, which is 1,000. If we're choosing one coin from the jar, the probability that it is a quarter is, as always, the denominator is the total number. So in this case, it's 1,000 plus 200 plus 40. And the numerator is our specific condition, which is that it is a quarter. And there's 40 of those. So 40 goes in the numerator. So we just have to reduce this to lowest terms now. So this is 40 over 1240. That looks like 4 over 124. Divide top and bottom by 4, and you get 1 over 31. So number 19, the answer is B. Each of PQR and STU have an area of 1. In triangle PQR, U, V, and W are midpoints of the sides as shown. In STU, R, V, and W are the midpoints of the sides. What is the area of parallelogram U, V, R, W? Well, what we can do is just draw a line from V to W like that. And if you do that, you will notice, based on the information given in the question, that each of these triangles is equal. So if I call this S, this is S, this is S, and so on. They're all equal in area. So they told me that PQR has an area of 1. So that means how many S's are in PQR? It looks like there's 4 S's, and that is equal to 1. So S is equal to 1 over 4. Now they want me to find the area of UVRW. UVRW is 2S. So 2 times a quarter, and that is 1/2. So number 20, the answer is B.